Okay, welcome to chemistry classes. In this video, we are going to discuss about mole concept. Mole concept part 2. You have to watch first part, then watch this video. Okay, so here we have to discuss here number of moles related to chemical reactions which involve gaseous particles. Chemical reactions which involve gaseous molecules, gaseous particles. Also, we will discuss here some calculation related to concentration and number of moles related to solution. So here we have to discuss here calculation of number of moles. It involved chemical reactions with gaseous particles. Okay, so to discuss these things, look here, you can imagine here, consider 5 different gases. Consider 5 different gases in different flasks. Each flask their volume 24 decimeter cube. 5 different flasks with different gases. Each flask their volume same 24 decimeter cube. Okay, so here also here the condition here 5 different gases with a different container, all of them their volume is 24 decimeter cube and all the flask in same temperature and pressure 20 degrees Celsius and 1 atmospheric pressure. Okay, so all of them are at RTP, room temperature and pressure. Room temperature and pressure mean 20 degrees Celsius and 1 atmospheric pressure. Pressure 1 and temperature 20 degrees Celsius. Okay. And here we discussed, I said here 5 different gases in 5 different flasks. 5 different gases in 5 different flasks. But their volume is same. Their volume 24 different gases. Imagine chlorine, hydrogen, oxygen, nitrogen and fluorine. So here 1, 2, 3, 4, 5. 5 different gases. Okay, and their volume is same 24 decimeter cube. 5 different gases with a different container, but their volume is same. Also their temperature and pressure is constant, same. So you can say the number of atoms will be same. Each gases contain same number of atoms. Same number of atoms mean each gases contain 6.02 into 10 power 23. This also discovered by Italian scientist Avogadro. That's why this is called Avogadros law. So according to Avogadros law, here 24 decimeter cube of any gases, it contains same number of atoms and we can say it is 1 mole gas. 1 mole gas. Okay, so here 5 different gases in 5 different container, their volume is same 24 decimeter cube, same temperature 20 degrees Celsius and 1 atmospheric pressure. Okay, so here gases are different, containers are different, okay, but volume same 24 decimeter cube, temperature and pressure same 20 degrees Celsius and 1 atmospheric pressure. Then we can say all these are 1 mole gas. All of them are 1 mole fluorine, 1 mole chlorine, 1 mole hydrogen, 1 mole oxygen, 1 mole nitrogen. Because all of them contain 6.02 into 10 power 23 particles. 6.02 into 10 power 23 atoms. This discovery also did by scientist Avogadro. Okay, so we will say Avogadro's law. According to Avogadro's law, 24 decimeter cube of any gases contain same number of atoms and it is called 1 mole. It is called 1 mole gas. Okay, so molar volume of a gas is 24 decimeter cube. Okay, so 1 mole gas mean 24 decimeter cube. 2 mole gas mean 2 times 24 decimeter cube. 3 mole oxygen gas mean its volume 3 times 24 decimeter cube. You understand? 1 mole. See here, 1 mole oxygen mean 1 mole oxygen gas mean 24 decimeter cube. Okay, 24 dm cube. So here 2 mole oxygen gas mean 2 times 24 decimeter cube. 3 mole oxygen gas mean 3 times 24 decimeter cube. Clear? So here we discuss here 5 different gases with 5 different container, their volume same, temperature and pressure same. Okay, so we can say all of them contain same number of atoms, and they are 1 mole. Okay, so all of them are 1 mole. So you can say, based on this, you can say 1 mole of every gas occupies same volume. Same concept I said before 24 decimeter cube of any gases, it will be 1 mole. Same thing, you can say 1 mole of every gas occupies same volume, 24 decimeter cube. 1 mole of every gas, their temperature and pressure same, 20 degrees Celsius and 1 atmospheric pressure. So 1 mole of every gas at this condition, their volume will be 24 decimeter cube. Okay, so two way I said here different gases with 24 decimeter cube, it will be 1 molium. It contains 6.02 into 10 power 23 particles. Clear? Or you can say 1 mole of every gases at RTP, it will be 24 decimeter cube. So here we discuss here 24 decimeter cube of any gas at RTP, it will be 1 mole. Any gas, for example hydrogen, oxygen, nitrogen, chlorine, any gas, okay, but the condition is here its volume is 24 decimeter cube, temperature, all of them, their temperature and pressure 20 degrees Celsius and 1 atmospheric pressure. Okay, so they will be in 1 mole. So gases, different gases, their volume 24 decimeter cube, RTP, it is 1 mole. So also you can say here 1 mole gas, 1 mole of any gas at RTP, it will be 24 decimeter cube. So here it is like this, x equal to y, so y equal to x. Same way you can say here 24 decimeter cube of any gas at RTP, it is 1 mole. So 1 mole of any gas at room temperature and pressure, it will be 24 decimeter cube. Also we know here 1 mole substance, we discussed before Avogadro constant. 1 mole substance mean it contains 6.02 into 10 power 23 atoms. So here we can say 24 decimeter cube of any gases at RTP, it contains 6.02 into 10 power 23 atoms. Clear? So here I will repeat once again. Here any gases at RTP, its volume is 24 decimeter cube, it is 1 mole. We know 1 mole substance, 1 mole hydrogen, 1 mole oxygen, 1 mole water, anything, 1 mole mean it contains 6.02 into 10 power 23 atoms. So you can say here 24 decimeter cube of any gases at RTP, it contains this much number of atoms. Okay, or you can say molar volume of a gas mean 24 decimeter cube. Molar volume of oxygen 24 decimeter cube. Molar volume of hydrogen 24 decimeter cube. Molar volume of chlorine 24 decimeter cube. It is does not matter it is diatomic gas, monoatomic gas, size of the particles does not matter. Okay, 24 decimeter cube of helium, it is 1 mole, same number of atom, it contains same number of atom. Okay, this number. Okay, also 24 decimeter cube of oxygen at RTP, it contains this much number of atom. So it does not change with helium, oxygen, water vapor. Okay, so you can take molecule, for example carbon dioxide, it is molecule. So 24 decimeter cube of carbon dioxide gas at RTP also follows same rule. Okay, so it does not vary with the size of the particles. Okay, large size molecules, small size molecules, diatomic molecule, monoatomic atoms, every gases follow same rule. Okay, it is proved by experimentally proved by one scientist we discussed, Avogadro. Clear? Okay, based on this we have one question here. What volume does 0.25 moles of a gas occupy at room temperature and pressure? What volume does 0.25 moles of a gas occupy at room temperature and pressure? So see here it is given number of moles of a gas 0.25. So what will be the volume of this gas? This is the question. Okay, so here we have to calculate volume. Its number of moles is given 0.25. So here we already discussed this equation. Number of moles is equal to mass over molar mass. Number of moles is equal to given mass divided by relative atomic mass or molecular mass. We already discussed. Using this equation you can rearrange this equation, then you can find mass is equal to number of moles times molar mass. This type of calculation already we did in part 1, mole part 1. Okay, now we have next one. This is for chemical reactions which involve gaseous particles. So here we are talking about calculation of number of moles which contain gaseous particles only. So here you have to remember, same way you have to remember another equation. Number of moles is equal to volume divided by 24. Number of moles is equal to volume divided by 24. Why here 24? It is constant because here we know 1 mole of any gases occupy 1 mole of any gases exist 24 decimeter cube. That's why here number of moles is equal to volume divided by 24. This 24 is constant for any gases. For all gases, this is the equation. Number of moles is equal to V over 24. So you can rearrange this equation. So volume equal to number of moles times 24. Volume equal to number of moles times 24. So here the question asking volume. You have to find volume. So what is the equation? How can you find volume? Volume equal to number of moles times 24. This is 24 common for all gases, oxygen, nitrogen, carbon dioxide. You can use 24. You can use this equation for all calculation related to gases. So here you have to find volume here. So volume equal to number of moles times 24. Number of moles is given 0.25 times 24. So you will get here answer 6 decimeter cube. So here 24 dm cube. For we know here this 24. 1 mole of any gases exist 24 decimeter cube we discussed. So 24 it is in decimeter cube. So here this answer will be the unit of this answer, unit of volume will be decimeter cube. Okay. Also you remember 1 decimeter cube mean it is 1000 centimeter cube. 1 decimeter cube mean 1000 centimeter cube. So you can convert this 6000 centimeter cube. Okay, so here answer will be 6000 centimeter cube or 6 decimeter cube. Okay, here next question. What volume does 22 gram of carbon dioxide occupy at room temperature and pressure? Here next question, 22 gram carbon dioxide. Okay, mass of carbon dioxide given. So what will be its volume? What volume will be accessed by 22 gram of carbon dioxide? So here mass of carbon dioxide given, so you have to find its volume. So you cannot use volume equal to number of moles times 24. Okay, here it is not number of moles, it is mass of carbon dioxide. So first you have to find number of moles. You have to find number of moles first. Look here, you know you can use this equation to find number of moles. Number of moles is equal to mass over molecular mass. Okay, so what is the mass of carbon dioxide? Mass of carbon dioxide 22 gram. And what is the molecular mass of carbon dioxide? Carbon 12, oxygen 16. So 12 plus 16 times 2. Okay, 16 times 2. So what is the molecular mass of carbon dioxide? 44. So 22 divided by 44. Okay, so you will get here answer 0.5. 0.5. Number of moles is 0.5. So now you can use this equation to find volume. Volume equal to number of moles times 24. So 0.5 times 24. So here it will be 12 decimeter cube. Okay, 0.5 times 24. So you will get 12 decimeter cube. Okay, so a 12 decimeter cube. You can convert this into centimeter cube. I told you before 1 decimeter cube mean it is 1000 centimeter cube. So here it will be 12,000 centimeter cube. 12 decimeter cube, or you can say 12,000 centimeter cube. So 22 gram carbon dioxide, its volume will be 12 decimeter cube or 12,000 centimeter cube. Clear? Okay, next one we have to discuss here calculation of volume from equation. Calculation of volume from equation. Based on this we have one question here. What volume of hydrogen will react with 24 decimeter cube of oxygen to form water? Here question. What volume of hydrogen will react with 24 decimeter cube of oxygen to form water? So here we have to calculate volume of hydrogen that will react with oxygen. The volume of oxygen given 24 decimeter cube. Okay, so here first we have to write the balanced equation. Write the balanced equation. Hydrogen react with oxygen form water. H2 plus O2 giving 2H2O. So this is the balanced equation. This is the balanced equation. Okay, and here we learned before, from balanced equation we will get mole. Here 2H2. So here 2 hydrogen, 2 mole hydrogen, 1 mole oxygen, and here 2 mole water. Here we have to calculate volume. Okay, here it is given 24 decimeter cube of oxygen. Oxygen 24 decimeter cube. Okay, and here you have to calculate what volume of hydrogen. The volume of hydrogen asking. You have to find volume of hydrogen reacting with 24 decimeter cube of oxygen. So look here, we learned before 1 mole any gas equal to 24 decimeter cube. 1 mole hydrogen mean 24 decimeter cube. 1 mole oxygen mean 24 decimeter cube. 1 mole any gas at room temperature and pressure, it will be 24 decimeter cube. Okay, so here you have to find volume of hydrogen. Its mole is 2 mole. So here 2 times 24. 2 times 24. So volume of hydrogen reacted here 48 decimeter cube. 48 decimeter cube. 24 decimeter cube. Here 2 mole hydrogen means 2 times 24. So 48 decimeter cube, or you can say, you can convert this into centimeter cube. 48,000 centimeter cube. Okay, so this is the answer. So simply you just write the balanced equation. So this is 1. So already it is given 24 decimeter cube. Okay, so here from balanced equation, the number of moles of hydrogen, it is 2. So here 2 times 24, so it is 48 decimeter cube. Clear? Okay, next question here. When sulfur burns in air, it forms sulfur dioxide. Sulfur after burns, it produces sulfur dioxide. What volume of sulfur dioxide gives, or what volume of sulfur dioxide produced when 1 gram sulfur is burned? Sulfur after burn, it produces sulfur dioxide. Okay, so after burning 1 gram sulfur, what volume of sulfur dioxide will be formed? Here you have to find volume of sulfur dioxide formed when 1 gram sulfur is burned. Okay, so here to find this answer, first you just write the balanced equation. Sulfur after burning, it produces sulfur dioxide. Sulfur after burn, it produces sulfur dioxide. Okay, here the mass of sulfur is given. Mass of sulfur. Okay, mass of sulfur is it is 1 gram. Mass of sulfur 1 gram. Okay, so here you can find number of moles of sulfur. Number of moles of sulfur is 1 divided by, you can find number of moles of sulfur. Number of moles is equal to mass over molar mass. That is the equation to find number of moles. Mass over molar mass. So mass is 1 gram. Mass divided by molar mass, molecular mass or atomic mass. Here sulfur. So you have to use atomic mass. Atomic mass of sulfur 32. So here number of moles of sulfur 1 over 32. 1 over 32, you can find this answer. It is 0. When you solve this, you will get 0.03125. 0.03125. 0.03125. So this is the number of moles. This means mole. Okay, 0.03125 moles of sulfur. So look here. Here 1 gram sulfur mean 0.03125 mole. So after burning this much sulfur, how much volume of sulfur dioxide will be formed? You know, to find volume, number of moles is equal to V over 24. So volume of sulfur dioxide, number of moles times 24. You need number of moles of sulfur dioxide formed. Then only you can find volume. So first we have to find number of moles of sulfur dioxide. That's why we are doing this. So here we calculated number of moles of sulfur reacted. So look here, using this equation, sulfur dioxide. We already discussed using balanced equation we can find moles. Using balanced equation, here 1 sulfur, 1 oxygen, 1 sulfur dioxide. So here 1 sulfur giving 1 mole sulfur giving 1 mole sulfur dioxide. Using balanced equation, you can say mole ratio 1:1. Mole ratio 1:1. Sulfur dioxide mole ratio 1:1. Mean 1 mole sulfur giving 1 mole sulfur dioxide. Using balanced equation. So here in actual this problem, here 1 gram sulfur means 0.0325. So here 0.0325 moles of sulfur giving how many moles of sulfur dioxide? Using balanced equation, 1 mole sulfur, 1 mole sulfur dioxide. So it is 1:1 ratio. So here 0.03125 moles of sulfur give how much moles of sulfur dioxide? 1:1 ratio. So it will be same 0.03125. 1:1 ratio. So here you can say 0.03125 moles of sulfur give same 0.03125 moles of sulfur dioxide. Clear? So here you can say number of moles of sulfur dioxide will be same thing 0.03125 moles. Okay, now you have number of moles of sulfur dioxide. Now you can find volume of sulfur dioxide. Volume of sulfur dioxide will be, this is the equation, number of moles times 24. We know number of moles of sulfur dioxide. Number of moles of sulfur dioxide is 0.03125 times 24. This is the equation to find number of moles of, this is the equation to find volume of sulfur dioxide. When you solve this, you will get 0.75 decimeter cube. When you convert this into centimeter cube, 750 centimeter cube. Multiply this with 1000. So this is the volume of sulfur dioxide formed when 1 gram sulfur burned. So here question asking, what is the volume of sulfur dioxide formed after burning 1 gram sulfur? So here we found the answer like this. We found number of moles of sulfur 1/32. We found this answer, number of moles of sulfur. Using balanced equation, sulfur dioxide 1:1 ratio. So using this mole ratio, we can find number of moles of sulfur dioxide, also same 0.03125. So we have number of moles of sulfur dioxide. So volume of sulfur dioxide will be number of moles times 24. So this value times 24. So 0.75 decimeter cube. To convert centimeter cube, we have to multiply with 1000. Clear? Okay, next one we have to discuss here concentration of solution. We have to discuss here relation between concentration and number of moles. Okay, so here first we have to understand here what is concentration. Concentration means amount of substance, amount of solute in gram or mole in 1 decimeter cube of solvent. Okay, so here amount of solute in gram or mole dissolved in 1 decimeter cube of solution. Okay, that is concentration. Okay, so here we already learned some equation to calculate number of moles, mass over molar mass. Also we learned number of moles is equal to volume over 24. Here related to concentration, we have to remember one more equation. Number of moles is equal to Cv. Number of moles is equal to number of moles. Also you can find concentration times volume. You have one solution, you know its concentration, also its volume. So you can find number of moles using concentration and volume. Okay, so after rearranging here, concentration mean number of moles divided by volume. Clear? Number of moles is equal to concentration times volume. So concentration is number of moles divided by volume. Clear? So based on this, we have one question here. 2.5 gram copper sulfate with water. This is hydrated copper sulfate. 2.5 gram hydrated copper sulfate in 1 decimeter cube. Here we have to find its concentration. What is the concentration? We have to find C, concentration. Okay, so how can you find concentration? You can find concentration C equal to N by V, number of moles divided by volume. Here volume is given, it is 1 decimeter cube. This is V, volume is 1 decimeter cube. You have to find number of moles. How can you find number of moles? Number of moles you can find mass over molar mass. Number of moles is equal to mass divided by molecular mass. Okay, what is the mass here? Mass is here 2.5 gram. 2.5 gram. Molecular mass of copper sulfate with 5 water molecule. Look here, copper atomic mass. Use your periodic table. You can find relative atomic mass of copper 64, sulfur 32, oxygen 16. Here 4 oxygen, so 16 times 4. Okay, here dot. Okay, so you have to add water molecule. How many water molecule? 5 water molecule. What is the molecular mass of water molecule? 18. So when you solve this, you will get 250. You can check it. This will be 250. Molecular mass of hydrated copper sulfate 250. So number of moles of copper sulfate, number of moles of hydrated copper sulfate here 2.5. So 2.5 divided by 250. 2.5 divided by 250. So here this answer is 0.01. 0.01. Okay, so here this answer 2.5 divided by 250, 0.01. This is number of moles. The question asking here, you have to find concentration. You have to find concentration. Concentration, number of moles divided by volume. What is number of moles? Number of moles 0.01 divided by volume. What is volume here? Volume is 1 decimeter cube. So what is the answer here? Answer is 0.01 decimeter cube. Okay, sorry, 0.01. Okay, and here unit of this mole per decimeter cube. This is the unit of concentration. Look here, concentration, number of moles divided by V. Number of moles mean mole, and volume it is decimeter cube. So mole per decimeter cube, that will be the unit. Okay, so here answer is 0.01 mole per decimeter cube. Okay, so here we did 2.5 gram copper sulfate in 1 decimeter cube. We want to find concentration. So first we have, this is the formula to find concentration. Concentration is number of moles divided by volume. Volume is given already here, it is 1 decimeter cube. We have to find number of moles. Number of moles is equal to mass over molar mass. Mass is given here 2.5 gram. So we have to find only molecular mass. Molecular mass of hydrated copper sulfate, it is 250. Okay, copper 64, sulfur 32. Here 16 times 4, 5 times 18, 250. So here 0.01. So concentration 0.01 divided by 1. So answer is 0.01. Number of moles divided by volume. So mole per decimeter cube. Okay, here next problem here we have sodium hydroxide solution. Sodium hydroxide solution, its concentration is given. Sodium hydroxide solution, concentration 1, number of moles 2, molecular mass 40, and we have to find its mass. We have to find the mass of sodium hydroxide in this solution. So how can you find the mass? How can you find the mass of substance? You have this equation, number of moles is equal to mass over molar mass. So here mass will be number of moles times molecular mass. Mass is equal to number of moles times molecular mass. So here what is number of moles here? Number of moles is 2. And what is molecular mass? Molecular mass is 40. Okay. So here it will be 80 gram. Okay. Mass of sodium hydroxide here 80 gram. So this is the equation. Number of moles is equal to mass over molar mass. So mass is number of moles times molecular mass. So here 80 gram. Clear? Here next question we have Na2S2O3, sodium sulfite, Na2S2O3. Okay, here we have aqueous solution of Na2S2O3 and its concentration 2 mole per decimeter cube, molecular mass 158, volume 250 centimeter cube. Here we have to find here number of moles. Calculate number of moles. So how can you find number of moles here? Number of moles. You have volume here, so you can use number of moles is equal to V over 24. Volume divided by 24. Okay. So no need to use these things. You have to find number of moles. Use volume. Number of moles is equal to V over 24. Okay, so here it is. See here, volume in centimeter cube. You have to convert this. You have to convert this into decimeter cube. You know, 1 decimeter cube equal to 1000 centimeter cube. Okay, so here centimeter cube you want to convert decimeter cube. Look here, centimeter cube convert into decimeter cube. So divided by 1000. So here it will be 0.25 decimeter cube. 250 centimeter cube mean it will be 0.25 decimeter cube. Now number of moles is 0.25 divided by 24. 0.25. Okay, here next problem here we have to calculate number of moles. We have to calculate number of moles of sodium Na2S2O3. We have aqueous solution of Na2S2O3 and we have to find its number of moles. Here it is given concentration 2 mole per decimeter cube, molecular mass 158 and here volume is 250. Look here, this solution volume is given 250 centimeter cube. Here you have to find number of moles. Okay, so here this is aqueous solution of Na2S2O3. You want to find number of moles. So you can use number of moles is equal to Cv over, you can use this equation. Number of moles is equal to Cv. Okay, number of moles is equal to Cv. So here you have concentration. So here concentration is 2 mole per decimeter cube. Then you have to times volume. Volume given 250 centimeter cube. Okay. So here Cv volume decimeter cube. Here volume in centimeter cube. We have to convert centimeter cube to decimeter cube. We have to convert centimeter cube to decimeter cube. We know 1 decimeter cube mean 1000 centimeter cube. 1 decimeter cube mean 1000 centimeter cube. So to convert 250 centimeter cube to decimeter cube, you have to divide. You have to divide 250 divided by 1000. 250 divided by 1000. So your answer will be around 0.25 decimeter cube. So remember this, 1 decimeter cube mean 1000 centimeter cube. Here centimeter, 250 centimeter cube given. So we have to convert to decimeter cube divided by 1000. So our answer will be 0.25 decimeter cube. That is the volume. So here number of moles will be 2 times number of moles is equal to Cv 2 times 0.25. 0.25. So here answer will be 0.5 decimeter cube. So this will be the answer, 0.5 decimeter cube. So here the question saying find number of moles of aqueous solution of Na2H2O3. Here concentration given, molecular mass is given, volume given 250 centimeter cube. Okay, so to find number of moles we will use this equation. Number of moles is equal to Cv. C mean concentration, V volume. So concentration it is 2, volume 250. Okay, 250 centimeter cube. To convert decimeter cube divided by 1000. So this is the answer, 0.5 decimeter cube. Okay, so these are the things we have to discuss in this video. Okay, rest of the part we will discuss next video. So thank you for watching this channel. You can watch next video. Okay.